Hello friends, welcome once again to uh, yet another tutorial of the Pixlpal firmware. In the last tutorial, we talked about the ESP IDF layout using the Visual Studio Code. In this tutorial, we'll be talking about the firmware layout, and that will include the various files that make up the Pixlpal firmware. You can locate all files here on the top right corner of the screen. Starting off, we have this directory here, which has the uh, .c++ file, CPP. As was mentioned, we use a combination of C and C++. So most of the source files will have the .cpp extension. On display is the main function where your program starts after various variables have already been loaded into memory. The program execution starts at this point. We'll go into further details when we begin to dissect the various APIs. However, for the purpose of this tutorial, we'll just stick to the layout. The first set of functions are used to initialize the system. That's the Pixlpal system at runtime, starting off with the memory or the file system for retrieving and storing files such as images or audio and the likes, or text. Initialization of the rotary encoder, other system components such as the status light, the GPIO, general purpose input output of the microcontroller ESP32, BLE, and Wi-Fi. Upon completion of initialization, the program moves next to launching a particular application. So usually, upon restart, the last saved application is launched. Or if you prefer various apps to be circling, let's say you have about 5 selected apps you want circling from one to the other at fixed time intervals, say every 5 to 10 seconds. If you have that activated, the app circling API runs, which gives you multiple apps. At the moment, you can see the Pixlpal running the New York Stock Exchange, the various stocks that make up on the New York Stock Exchange, showing the various stock prices and various metrics, showing the performance of a particular stock. This app is the last app that was run, and it's fixed. It's a single app without moving to others. I would go ahead and restart the Pixlpal device so you'd see that demonstrated. While that goes on, we'll talk about the other folders. Or to kick off, the folders of particular interest, except for very advanced users, will be the components directory, which has all the apps and the various component and libraries. Some are user created, some others were developed in-house. For instance, those that have the prefix of metabit, that's these various directories were developed in-house, whereas those without the prefix are user contributed open source libraries or components. You can see the Arduino core equally here, having all the core Arduino libraries and APIs. Within the component folder, we have the various apps developed for the Pixlpal. The way the firmware is structured is that every app is a component on its own. In the examples directory, we have various examples which uh, developers can access to learn how to use the various APIs. For instance, this example demonstrates how to draw images to the Pixlpal display. We'll touch on that later on. This folder contains all both completed and apps that are in development. We have about 20 apps if you count. About half of them are completed, while the rest are currently in development. Moving on. Okay, we've touched on the main folder. Now we have the managed components. These are components that are automatically installed from the ESP IDF component registry. Some of them are developed by Expressive, while some others are user contributed. For instance, these prefixed with Expressive are official Expressive components, whereas those without the prefix are user contributed. Typically, these components are installed automatically after running a series of code, which we'll touch on later on during at a later episode of this tutorial series. But the key thing here is you are not expected to make changes within this folder. Making a change within this folder, you can access them, the content. However, making changes usually breaks the code. For instance, I wouldn't do one, but I'll just access the USB host. This particular library is used, or component is used, to drive the ESP32 for audio applications. Opening a particular program file, you can see the various program. Making changes here usually causes error. They are expected to be managed by the ESP IDF automatically, including making updates to the libraries. So I'll just leave that as it is. These are other items of interest, files of interest. However, those are for advanced uses. I'll just quickly describe them. We have the partition table that shows how the memory layout of the ESP32 SoC is laid out. We have the over-the-air partition, which is about 6 megabytes. We have two of them. This allows for OTA updates. We have data storage. About 3 megabytes was dedicated for data storage, whether images, audio, or text files. We equally have the NVS storage, which has about 480 kilobytes of memory dedicated for storing NVS parameters, non-volatile storage. That's the full meaning of NVS. So we particularly use this memory to save settings. For instance, the app currently running have about 3 selected stocks. You can select as many as you wish, 10, 20. However, when a selection is made, that settings is saved in the NVS memory. We'll touch on that later on. So typically, you are not expected to make changes within this file. And the parameters within the file, they get compiled. At compile time, they get built into the final binary file, which will be flashed into your expressive uh, module or SOC. Um, I think these are the key files of interest. We equally have the SDK config. You are equally not expected to make changes directly here. To make changes, you use the SDK configuration editor here, which we talked about in the last tutorial. So changes are not made here directly. So the key folders or files of interest is the main components, as well as those are the two. Now I'll touch on two other folders, which is the build. Upon compiling your program, the build folder is created with various build files, which include the binary file, which is being flashed to, it contains the program sequence your Pixlpal will be running. This will be flashed to the memory of your Pixlpal device, of which the program begins to run. We typically, for advanced users, making changes here, except for advanced users, making changes here is not recommended. I forgot to mention, within the main folder, you have predefined system files. This folder contains some of the various icons you see within the Pixlpal. They are preloaded, and at compile time, these files and folders are loaded into the um, memory. That's the file system memory of the Pixlpal. For instance, you can see these icons here that represent Wi-Fi connection, internet connection, as well as BLE or mobile app connection. Those files are preloaded within these folders. It's equally advisable not to make changes here. Those can be done at some other means, which would demonstrate in subsequent tutorials. I would launch one of these, which is App Circle. The image is quite tiny. Let me see if I can expand it. Okay, so this is the icon, which is already saved here. So that's much about it for the Pixlpal firmware layout. In subsequent tutorial, we'll kick off, or we'll start off with the layout of the firmware itself, which is the layout of various applications, or a typical application, how it is structured, and how you can go about building one. Thanks once again for your time. I'll see you in the next tutorial.